Hello guys and welcome to Freebird Student. Welcome to 75-day Hard Generative AI Learning Challenge, and this is day 36. And in this video I will tell you how you can build your own AI applications for text to image. And we will also cover all the text to image stable diffusion models with their Python implementations as well. Okay, so let's get started. So very first thing is how this text to image happens with the help of stable diffusion models. Okay, so let's learn about that first. Okay, so very first thing is it takes your input prompt and convert that prompt into the text encodings, and then these text encodings are gone into your conditional generation. And with the help of this conditional generation, here a little bit of the noise is added into your text embeddings, because with the help of this noise only it is able to generate the final image. Okay, then this whole thing get transferred into the diffusion model as well, and this diffusion model has the architecture of the AutoEncoders as well, an encoder and also a decoder, with the help of which we can get our final image back. Okay, so internally if I tell you the overall process, it works like that. The diffusion steps, it reconstruct the image again, and then it will add more noise into it, and then this whole cycle will again run in the loop until the final clear image we have gotten. Okay, so this whole step will run in the loop as well. Okay, so now let's talk about the stable diffusion architecture. Okay, the stable diffusion is based on a type of diffusion model that is called the latent diffusion. Okay, and if you want to learn more about this, you can learn in this research paper as well, and I will put the link in the description, because this research paper contain all the minute details that you can learn that how this stable diffusion completely works. But if I am going to explain in this video is like that, these stable diffusion models are actually a generative models that is trained to denoise an object such as the image or to video as well. So that the model is trained to slightly denoise the image at each step until the sample is obtained, until our final image we can get. Okay, so this process works as I shown in this slide as well. Whenever the first we have this completely noisy picture, and then slightly it converts into a beautiful scene as well. Okay, so these diffusion models have gained popularity in the recent years because of their state-of-art results in generating the images. Okay, latent diffusions. These reduces the complexity and memory usage by applying the diffusion process over a lower dimensional latent space. And in latent diffusion, the model is trained to generate the compressed representation of the images. Okay, so in this way, this whole diffusion process works that can generate your images at the end as well. Okay, so this whole stable diffusion is composed of the three components. The very first component are AutoEncoders, that is also called as variational AutoEncoders, and then we have the unit, and then we have the text encoder. Okay, so let's first talk about the AutoEncoders. Okay, the AutoEncoders are actually the variational AutoEncoders that consist of both an encoder and decoder, and while the encoder is used to convert the image into the low dimensional latent representation to serve an input to the unit model. Okay, so this serve the input to the unit model there, and then the decoder transform the latent representation back into the image after the unit transformations. Okay, so now let's learn about what is actually this unit is. So unit is actually a type of a convolutional neural network that is widely used in the image segmentation task, because we have to generate the complete image segment by segment. Okay, it also has an encoder and decoder, both comprised of the ResNet blocks. Okay, so it has its own encoder and decoder that is consist of the ResNet blocks, and the encoder compress the image into the lower resolution image, while the decoder decode this lower resolution image back into the original high resolution image, which is supposed to be the less noisy, because in this way its whole noise and denoise work will be done inside the unit as well. Okay, and then we have another component that is called as a text encoder, because this text encoder is responsible for transforming the text input prompt into an embedding, and that can be understood by the unit. So it is usually a simple transformer based autoencoder or the encoder that maps a sequence of input tokens to a sequence of latent text embeddings only. Okay, so in this way this whole things will work. Okay, now you understand that how this whole process is going to work with the help of text to image, these three components. These three components are the part of stable diffusion, all the models. Okay, now let's go to the part of our Hugging Face library that has the text to image library there. With the help of this diffusers library, we can build our own AI applications for text to image as well. It has everything. It has everything you need from the stable diffusion pipelines as well, and from the every function or the method that you can use to build your own AI application for the stable diffusions of the text to image as well. It can use only the stable diffusion diffusers library, and with the help of that you can build your own text to image pipelines as well. Okay, so now let's get started to build our own large language model here. With the help of stable diffusions library, we can build our own multiple text to image applications with multiple stable diffusions language models as well. Okay, so let's get started with that. So here is my text to image stable diffusion notebook, and here you see I have used the diffusers library. So the diffusers library is a go-to library for the state-of-art pre-trained stable diffusion models for generating the images, audio, and even the 3D structure of the molecules. Okay, and the stable diffusion diffusers library has three main components. The very first component is the state-of-art diffusion pipelines, and then the interchangeable noise schedulers, and then the pre-trained model. You can use everything in your projects to make a good text to image model. Okay, so I will show you that how these three components act in the stable diffusion text to image conversion. Okay, so very first thing, we install the diffusers library here, and then we have the torch, because every model in the stable diffusion is built by using the pytorch, so that's why we need the torch library. And then we get the stable diffusion pipeline to get the pre-trained stable diffusion models, and then we have the PIL, because we need to build or visualize the image as well by the weights or the metrics returned by the stable diffusion pipelines. So the very first thing, I use the stable diffusion latest pre-trained large language model, that is version 1.4, and along with I load this model in the format of float 16, because I need to be it in a lower precision for the fast processing. Okay, so here I just write down the name and get my pre-trained stable diffusion 1.4 model. Okay, so then I also create a function as well, because whenever I ask my stable diffusion model to give me 6 images or 3 images or 2 images as well, I need to show those images in the form of rows and columns in a correct size as well. Okay, so for that I build this kind of a image grid function that takes the images variable and show them in the form of rows and columns. Okay, so then I also move my whole pipeline to the GPU as well, because I am here using the Kaggle notebooks internal GPUs. Okay, so now here I give him a prompt with the help of n images. I need 6 images of this prompt. Okay, and with the help of this prompt and my above function, it generate me these 6 images. Okay, so as you see, with the help of a single prompt I created these 6 images, and these images looks very promising as well. Okay, so now I use the same kind of a pre-trained model and generate another image with the another prompt. I write skyline of the cyberpunk megalopolis, and it shows me this view, and you see that this view looks so amazing and so realistic as well, because these images are generated by the stable diffusion models. Okay, I hope you guys completely understand that how I load Stable Diffusion's pre-trained models and how I show them in the screen as well. Okay. So now there is a one note as well, because when you are building a pre-trained large language model by using the Stable Diffusions, you change some weights, or you can also tweak it as well. So you can also store your pre-trained large language model in your local system and can also get the same kind of pre-trained large language model with the same kind of weights and settings by using the checkpoints and by using the auto pipeline for text to image class as well, which can load the same kind of model that you stored in your local system. Okay. Now I use the Runway Stable Diffusion large language model because this is the more advanced large language model available in the market as well. Okay, so here I use the same kind of class here, auto pipeline for text to image, and from the pre-trained model I get the Runway Stable Diffusion 1.5 version in the float 16 precision. Okay, and I also load it with the help of GPU. Okay, so it load my complete model here, and then I just give him a prompt that Darth Vader with Death Star on a planet, black light, every kind of thing I want to give it to him and get the image at the 0th place. Okay, so it shows me the image. As you see, this image is also looks very, very promising as well. Okay, now we have the most common text to image models that are like Stable Diffusion 1.5, Excel or Kandinsky 2.2. Okay, so very first thing I show you that how Stable Diffusion 1.5, that is the latent diffusion model, initialized from the Stable Diffusion 1.4, and it fine-tuned for 595,000 steps on the 5212 by 512 images from the LAION aesthetics V2 dataset. So this images are like very, 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 very fine-tuned because Stable Diffusion 1.5 is already a very fine-tuned version of the Stable Diffusion 1.4. Okay, so I just load the Stable Diffusion 1.5 from the Runway ML here as well, and then I give him a prompt as well, and with the help of the prompt I also give him a generator, because with the help of generator it can generate the image faster on the GPU. Okay, so here it generate the image. I just see this image is also look quite realistic but not very detailed here. Okay, so let's enhance this image more with the more enhanced large language model. Okay, so now I use the Stable Diffusion XL, and Stable Diffusion XL is the much larger version of the previous Stable Diffusion model that we used above, and it involved two-stage process that adds up even the more details to the image, and it also includes some additional micro conditioning to generate high quality image. Okay, so now I use the same prompt as I use above with the help of this Stable Diffusion XL model here, and with the help of this XL model I get this realistic image. I just see this image looks more enhanced or more detailed than our previous image as well. Okay, so now let's make this image more detailed as well. Okay, so now we are using the Kandinsky model, which is a bit different from the Stable Diffusion models because it also uses the image prior model to create embeddings that are used to better align text and image in the diffusion model. Okay, so it used the prior model as well. Okay, so here I just get the Kandinsky model here, and I use the same kind of prompt as I use above, and I try to get it. And as you see, this images also looks quite good, but details of the face are completely missing here. Okay, so you can like make these images like looks more enhancing and more promising as well if you have a good computer system with large number of GPUs on it. Because if I load this model with float 32, float 64, then this model will generate more detailed images as well. Because of the low precision, some accuracy will get lost as well. Okay. I hope you guys completely understand that how you can use the Stable Diffusion all models to generate your own realistic images and to use them in your own projects for the AI as well. So in our next video, I will tell you how you can use the vector databases to build your own chatbot by using the large language model. Okay, we use the Pinecone vector database to build a chatbot with the help of large language models and LangChain as well. Okay, and if you want to know more about prompt engineering, data science, statistical modeling, financial data modeling, you can check out my videos on YouTube and also read my blogs on Medium. We'll meet in our next video. Thank you so much.